Hello everyone and welcome to today's XP Live webinar. My name is Catherine Tran and I'm part of the marketing department here in the XP Solutions Portland office. So today's webinar will demonstrate how xpdrainage stormwater design software can help designers to automate and streamline the process of designing stormwater systems and for reviewers to clearly review and approve these systems. So if that's a topic that you're here for, then you're in the right place. So one more note here for those of you who may not be familiar with XP Solutions, we have a long history of providing high-performing software solutions. And our intention is to make sure that in your work, you can model with confidence. This means that we strive to provide excellent customer service and support and that we offer continuing education opportunities like these for engineers in our industry. So today's presenter is Zack Sample, our Stormwater Products Manager. He has over 10 years of civil engineering experience in site design, stormwater planning, and hydraulic analysis. Zack has performed a number of advanced water resource studies, including hydrologic and water quality system assessments, as well as 1D and 2D hydraulic river and floodplain studies. During his time with XP Solutions, Zack has helped hundreds of clients with their models, so his voice may be familiar to some of you. So thank you all for joining us today, and welcome, Zack.
Hi, thanks, Catherine. Thanks, everyone, for joining. We'll jump right into, I've got a question for everyone here, just to kind of see what everyone's thoughts are on the following subject. So this is about kind of what is the stressor in your job, in your work. Okay, that's something that I think about quite a bit. So go ahead and click on these. You can see there's unpredictability of site changes. Again, this is all kind of around the stormwater design topic. So unpredictability of site changes, high number of iterations needed to really complete a project, time it might take on the back end to update CAD with the design, creating reports and plans. So go ahead and click through some of these. Looks like most people have already jumped onto this, but let's give everyone else a few more seconds. And I'll share the results here, actually kind of interesting stuff. Okay, that's great. All right, so I'm going to close that and I'll share. And yeah, pretty interesting to see here that, it looks like a lot of people have really run into all of these items, have really been kind of a thorn in people's sides, but looks like the two kind of independent stressors is, that maybe things out of our control, right? The site changes that, maybe we aren't dictating if we're doing stormwater design, but that might be someone else hands us. So unpredictability of the site changes and the high number of iterations needed to complete a project. So that's great. I want to start today with this in mind. So with this in mind, today we're going to talk about three kind of basic ideas here. We're going to face our problems, see our problems, find an answer, and ultimately see what I kind of call peace of mind in action. So we really, with this poll, started to look at some of our problems, some of our stress. Let's kind of dive into that. So engineers, civil stormwater engineers that are doing design need to answer the following questions. So first, we need to find how big or small a stormwater management system needs to be while safely mitigating runoff impact. So what's the required size of these facilities? And then immediately after that is, does this fit on the proposed site? So we need to figure out how big it is. And then also, well, does that thing fit on our site as it's currently laid out? So designers need to finish their project on time and perform the right calculations. So right calculations is really in terms of local design guidelines, which might have a slight variance all across the country, but largely they all follow the same general criteria. So for the design engineers, on time and correctly. So let's look at reviewers. Reviewers of these designs, well, simply put, they need to understand the design intent behind the submitted proposed development project, right? So there is work that was done, and these reviewers have to just fully understand the intent behind that. So that might take a little more deciphering, but that's what they're trying to do. That's what they need to do. The second piece is they need to verify if this system or this treatment train will actually behave as presented and meet the local guidelines. So the priority for these reviewers is on improving safety, constructability, and long-term success. So for them, just simply understanding clearly the project is paramount. So this is directly related to how clearly all the design, all the details are communicated from the consultant. To further illustrate what I mean by completing a project the right way. So here's a bit of an image. So US storm designers have to pass a number of milestones, I might call them, one way or another in order to complete or in order to submit their proposed design. So you can see some of the labels on these items, but starting at the top, you have to work your way down through all these hoops. So it's, complete a range of hydrology runoff calculations, water quality volume sizing, pipe network sizing, then move into pond and outlet sizing. All of these individual items ultimately need to be assessed in kind of an overall system assessment to prove the soundness of these individual items. So several tools may be used for each step, but ultimately all this information needs to be clearly communicated, as we just looked at, from the water resources team out to the greater site team in your company, or when you submit, that's ultimately needs to be communicated to the local municipality for review. So this overall process, this workflow, with all its potential for inconsistencies and problems, is something that we've worked with the engineering community to streamline and improve. The result being xpdrainage. So xpdrainage with Civil 3D CAD integration is a powerful workflow solution, that workflow we were just talking about. So xpdrainage automates the design and assessment of stormwater systems and is enhanced by one-click optimizing for all runoff reduction practices. This allows for sustainable drainage plans that are quick to assemble, clear to communicate, and thoroughly reviewable. xpdrainage will help you to complete projects before their deadlines, present very clear and understandable reports to constituents, and be more confident in your overall design because it's integrated with your current CAD drawing software. Putting this reliability and efficiency at the forefront of the product vision is why I'd say that we didn't make xpdrainage just to design stormwater systems. xpdrainage was made to give you your weekends back, as we had stated in this webinar. Giving you weekends back in successfully submitting quicker on every project. xpdrainage is an efficient and thorough stormwater design solution that is integrated into your tools that you use, like Civil 3D, so that everyone on your team can wrap up their work and get out of there. So I want you to see for yourself what I'm talking about. So let's jump right into some project work with our latest release of xpdrainage 2017.2. So here is xpdrainage, right? When you first launch it, we wanted to show kind of the full kind of feeling of the product. When you first open it up, you can jump into some tutorials, look at some videos, really easy way to kind of get started, even if you haven't used this before. So we can start. I'm just going to pick a project that I was just working on, and I'll open that. And before I show this commercial project and some pieces that we're going to really commonly use, I might actually show the main premise of xpdrainage. So if you've seen webinars before, you might have seen this following concept, but this is what we're going to look at for xpdrainage. So here is, we have a system. We're going to build this all up in a moment, but the main concept, if I had to say there's one thing about xpdrainage that is really unique. So here is the layout for this happens to be a rain garden, but this could be a pond, okay? And all of this input data is always locked into what's shown in plan view. So fundamentally, how we're going to clearly represent and understand our designs is we're always going to show kind of that as-built layout and really the true to the real world connectivity of a system. So here's the real location of outfalls. Here's the actual overland flow and underdrain lengths. Okay, and here's the actual footprint of this facility. If we were to change some of these items, if we were to, let's say, change the side slope, okay, this is just an easy example, change some of the dimensions, well, that's always going to be represented in this plan view. So I mentioned, what do design engineers need to do? They need to figure out how big it's going to be, and then really kind of instantly, does that fit on my site? Well, that's what we're doing with drainage. We kind of merge those two together. So we have a range of automated and kind of smart ways to get your sizing and get your system to be the correct right size. But it's instantly showing against this background information, does it work or not, right? So looks like this just barely works on my site, okay? Any bigger? Well, I would instantly see that I would need to maybe split this pond up or change the layout. So that's really the backbone of xpdrainage, is we're always going to be able to see how the system is going to work if it will fit on my site, okay? And that is a real big pain point, something we talked about in the polls earlier. Unpredictability of site changes, number of iterations needed. We are absolutely cutting all that down. Okay, so iterations to get things to work. Well, a lot of that's just making it fit. And site changes, you can then have your CAD file just refresh the background, and you would see changes, and then we could just adjust our system accordingly, and it would instantly be represented in our calculations. Okay, so that is really the kind of a kernel of what xpdrainage represents. So let's look at maybe a larger project. All right, kind of a blank project space, and I'm going to work through some really kind of maybe the common way you build up a project. All right, so there's all this integration that I've mentioned that we talk about for xpdrainage. Well, let's just kind of explore what that means. So the first thing I could do, so this is a commercial block. I happen to have this developed phase that I want to populate. Okay, I'm just going to jump right into, let's just start bringing in data that we have. So I could right click on inflows, and I can load from CAD. You'll see there's also load from GIS. We'll do that in a second. So I'll pick this CAD file. We'll see that it has some catchment data, and I can select a template. So I have this commercial land use template. I can select that. Easy enough. And we are importing all of these catchments. So really faster than I could even say it, we have imported all of these inflow areas, as we'd call it. Okay. So we can look at one. You'll see here, I happen to be using this Santa Barbara runoff method. We have a range of methods. SCS is probably the most common in the US. You see here, that's what we've brought in. Not only these shapes, but based on how they were drawn, right? The area is already set, and using that template, all of the runoff properties are going to be designated for us. So great, so that's inflow areas. I happen to have that data sitting around. Maybe I also have some of the pipe network information. I might have that in CAD or GIS. Maybe I can, so I'll load from GIS just as an example. So here is my pipe network. You can see here this small image of kind of what it is we're dealing with. Well, it'll make more sense once I import it. And I can select if there's any missing data. All right, so it's pretty helpful if there's gaps in the information in the data. Using a template allows us to kind of fill in those missing pieces. So those templates were for if there's no junction data, right? What junction, what kind of manhole to use. Same with the pipe information. If we don't have diameter, let's say, well, the standard diameter size from the pipe would be used. You see, I could map these items here. I mean, pretty obvious kind of what it is we're doing here, but diameter is in the attribute file for that GIS shapefile, and here I could map diameter to that. I can also load in, it just takes a second, but just to show that you can, I happen to map this before and I just saved that mapping. Okay, so I can now import, and we'll see that sure enough, we have now not only brought in this pipe network, but also, since we have these junctions, this system that kind of came in with our inflow areas, you'll see that all these inflow areas were really automatically associated. So I don't need to now kind of manually associate these. It automatically found that, hey, this roof area, well, this all drains to this downspout, right? Here's this little lateral. So we automatically connected that, right? So it's pretty useful to get us kind of moving ahead pretty quickly. So from here, I have my pipe network. I have all my catchment, all my inflow information. So this, I guess to pause for a moment, this pipe network, this might have originally come, again, this came from GIS, similarly with CAD, if you have, let's say, Civil 3D. Pipe networks and, land XML have to be usually oversimplified. Okay, so in the real world, what we need to do here is we need to put an underground vault in this lower portion of our site. Okay, well, if you're trying to make a pipe network in Civil 3D, well, there's no underground vault type of element for a pipe network. So what lots of people do, and this is what I used to do as a consultant, is I would kind of put dummy objects into a pipe network. So this is really kind of a dummy placeholding object. So, well, xpdrainage, again, we want to represent the as-builtness, the true to life, true to final construction of the project. We think it's really important to be able to assess that. So what we're going to look at is I can just very easily take what has been simplified, these kind of dummy objects, and I can just simply change the template. So I could go to all of these different stormwater controls, we call them, different ponds or manholes, and I happen to have this vault structure that perhaps I'd used before, and click OK, and we'll see that this, right, not only is it the outline that was saved in there, but also all the details for the stormwater control. So here is just 4 feet deep, and based on this layout, okay, we have this area and the storage. Here's an image showing kind of what we're talking about. This is that classic, I'll call it milk crate style structure underground. You'll see based on the manufacturer's specifications, hey, it's about 95% void ratio. 6-inch freeboard, okay, we might see that come into play later. Freeboard is just kind of a little warning indicator. Maybe you want to start paying attention if it gets up this high. So, great. One thing we could do, we could add in an outlet. So by default, this is a free discharge. I might make this a weir, and I already know how this would be constructed. Maybe by default, there's a 3-foot wide weir, within that top 6 inches of the structure. So I'll make this be 169.5. See, any red value is something that's kind of overridden and automatic. So that invert level was automatically set there based on the invert level from that first screen. So a red value means I over-typed that, overrode that. So that's it. So that's great. So we now have this structure with an outfall. We could pretty well run them all right now. One thing I'll call out is, well, we happen to have these pipes kind of connecting this icon still, right? This was a simplified idea. Well, what we can do, we can go right-click on a stormwater control, and we could start placing these inlets. So this would be the inlet to our system or the outlet. So here's the real world position of some of these things, right? So this, it might dump out into this corner and this corner of our facility, and likewise it could perhaps discharge. Okay, I want to show that vault right there, and here is the discharge point. So now we have the true lengths of pipes and of course the slopes. Something else we might notice if we really look at this is that the software is kind of half smart, I like to say. So it's really, really useful, helps us do our job quicker. But of course, you can see here, it's not going to fully replace our job. So this inflow area, well, it automatically snapped to the downstream structure, right? It didn't realize that, well, we're really going to need to drain into this vault. So what we could do is we could just reconnect that inflow. So perhaps this surface lot drains into a inlet right here that goes down into the vault, okay? So what we'd find is, well, we need to perhaps, there used to be 2 inlets into this manhole. Well, now there's just 1. All right, and that's it. So one thing we could also set up is this outlet. So the ultimate outfall. This is something new to 2017.2. Really, really useful. So this is a way to designate outfall details. So usually it's just a free outfall, or maybe there's a fixed level. Okay, those are probably the 2 most common. But you know, it's kind of one of those 1 in every 10, 1 in every 20 projects. Someone needs to be able to specify a variable outfall level at the downstream edge of the site. Maybe you're outfalling into a creek, right? So we could have a variable surcharge level. And you know what? I happen to have loaded in a curve. So here is our downstream boundary curve. And what's really, really useful here is that, so not only can we now specify a curve for an outfall, but we're going to be able to set up a curve for each outfall for each rainfall event. So really a matrix of, in the real world, you'd probably have a different flooding condition at your 5-year versus 100-year. Maybe you have the same overriding hydrograph, but you can absolutely very easily specify, I guess have the 1 outfall, but you could have a whole range of outfalls from your site. And for each rainfall event, apply a different variable curve. Okay, I might be kind of geeking out at this concept, but this is something that is, you know, really no other software has this ability to control this easily. This is a really robust item, though again, maybe 1 in every project, 1 in every 20 projects you might run into this, but one of those things that if you need it, this is, you know, invaluable. Okay, so that's also shown here, this outfall details icon in our layer tree. Same thing. So that's great. So I specified that outfall. And what we're going to do is we're going to, very realistically, I'm going to validate this model. And we're going to see, oh, right, what happened? So there are some warnings here. So let me just show, right, part of being able to understand and visualize these projects, right? So we can see in plan view, really important item for us would be to see a profile. So I might show this profile here. This is something else that's really been further improved here in this latest release. You can see how we can really zoom in and understand what's happening. And you can see the manholes and the pipes aren't copacetic. They aren't really working together. And that's what those warnings are. So this is something which very easily could be overlooked. So in a project, if you're just typing in data between different programs, if you are kind of independently designing things, just basic levels and how they, you know, will something truly gravity drain? That is probably, in my opinion at least, and for me, was probably the most common thing that I would, you know, I'd mistype something or just it wouldn't come together. Okay, so this, and really the way to zoom in here, this profile update, as well as the really enhance the GIS importing, those are things in this latest release that I think are really quite useful. So we can really see what's happening. And from that validation, before we run the model, you'll see that, hey, it's letting us know what's happening here. The first 2 items are the ones, hey, the inverts for all these different manholes are higher, and all these different manholes, the inverts are lower, right? They didn't get snapped to the pipes, but we can fix that right now, right? So I could apply that, and sure enough, that corrects all the problems. So we could look again at that profile, and sure enough, right? Basically, all we said was, hey, drop or raise those manholes so that they're at the correct elevations. So it's easy as that. So I could now run this assessment. I'm running a range of rainfall events. So we'll see here, I have 3 different phases. I have an existing site, the development project we've been working on, and one that's slightly different. I believe the other project is using the SCS hydrology. We might see a little difference in ultimately in our runoff characteristics. So I'll show that right here. I have the 3 different phases, so existing, developed, and final. Okay. So great. So we have now just run this assessment. Let's just kind of see where we landed. So what pops up when you first run it is this stormwater control summary. This is really, really useful to give us an overall view of how all of our facilities, all of our ponds behaved. So we could look at perhaps all storms. You could see how all of these items impacted our site. Remember, this vault is 4 feet deep. So we're right here getting towards the top of our facility, right? And percentage available, this is kind of the most common thing, the most important thing for us when we're designing. I want to glance at this and go, what percent extra space do I have, right? So in the water quality event, we are, over 90% extra space. Well, that's kind of expected, but we're probably infiltrating a lot, so we aren't actually having any discharge in our runoff event. Well, that's what we want. The higher events is what this vault is designed for. And you'll see, -4, -10%. Well, that all has to do with our freeboard. Okay, so this starts counting at your freeboard elevation, and you can see over here, right, we're at 3.9 feet of water depth. Well, our facility is 4 feet deep, so we're just towards the top. So this is actually okay. This is great. And that's one thing I use the freeboard for, is to really let myself know how close we're getting to the top, and to see if some facilities, this one might not be that case. You can fully fill this one up, but if it's a pond or a rain garden, you might not be allowed. There might be an ordinance against filling up to the brim, so to speak, so that you might see something and go, you know what, I need to knock this back down to keep that water level below the freeboard. So we could look at just these, a summary of results. Critical storm is pretty interesting. Oh, here it is, highlighted what the critical rainfall event was and what those levels were. So that's really useful when you have a whole range of rainfall events, and seeing the timings, kind of how those behave. Usually, of course, the most dominant 100-year storm is going to be the top. So that's just our from the hip summary of our facilities. We can look at all the connections. We can see, I might change this to be the 100-year event. And we're trying to show information 18 different ways. So I could look at a summary of results for all of our connections. These are all of our pipes, okay? We're going to highlight in red areas that might be a problem. So right here, we're going to see, well, we have flow over capacity. So the flow going through this pipe is greater than the capacity in that, with the Manning's equation, capacity, pipe full flow would tell us that it should hold. So this is also shown in plan view. You can see this red item. Well, it's right here. This is maybe a lateral coming right off a roof. This is a 4-inch lateral. Okay, well, it's undersized, pretty easy. We would just kick this up to be a 6-inch pipe. All right, we could even look at the input for this item right here. So I've selected that. Sure enough, 4-inch pipe. And I could upsize that, right, and rerun the model. Okay. We could dive even further into some of the results to understand this. Phase report is probably the most common. I want to see, not only does I'll go right to the worst case, the 100-year event here at the bottom. So here are graphs. You'll see here I could zoom right in here on the graph and understand what's happening. All right, so here is inflow and outflow. And we'll see existing outflow is about 1.9 CFS. you'll see that both of my developed conditions are attenuating that properly, right? So that's great. You'll see there's a difference in the flow. I believe I had one site set up using the SCS method, which was a little different than the Santa Barbara method I was using. Okay, but we can see, right, very easy to understand. I might even turn the graphs off. We could just look at just a tabular display. Great. Go down the list. All my storms are getting reduction, and I can compare all these different phases, all these different design scenarios side by side. All right, so that's really quick and easy to see from the designer's point of view. Yes, it looks like I have the right size of reduction, the right facilities. We could dive into some individual, let's look at this vault. We could look at the different graphs. I might just dive into just total inflow and total outflow. Right, and you can look in here and really see these graphs are great for timing, right? You can really understand the effects that are occurring throughout the system, okay? And ultimately, we can look at all the details. We can itemize each inflow into the system, each outflow point of this facility. So all this information is kind of at our fingertips. And once again, really useful to be here looking at the profile to once again understand what's happening. This is the 100-year event, and I can look at the flow through this. These are kind of flood warnings. Say, oh, you're almost at the top. You're almost surcharging these points. Okay, that'll also be shown in plan view. Okay, so this information we're seeing a number of times. We're trying to make it very difficult to ignore it, to not understand that this is getting pretty high. So great, we've laid a system out. We've run the assessment. Looks like it's going to work. So the big piece here is, well, let's kick this information back out. That's really the most useful thing for us. Okay, so that's a real strong point of xpdrainage. So we might, I guess, what are all the things we could think of? Let's start with, we could export a pipe network. So once we have laid this out and perhaps changed some sizes, we could export. Easy as that. So I happen to have this submission folder. Great, so I'll save my, so there it is, my pipe network. So I could instantly have that read back into CAD, or I could export this and have that loaded into GIS again. Okay, I could now also save all of my work out into CAD, and we'll see, I can load this into another model. We see what it looks like, but this is all of our system with all the attributes. So with the pipe network, with all the details from our plan, someone could complete the final grading in Civil 3D very, very quickly and easily. There's no manual updating of where the facilities are or how they are going to be put together. All that information is really pushed right out to CAD. All right, save CAD. Great, and I could save that file. I actually have the option here of all layers, just visible layers. I might say just the visible layers. So, all right, we have all the plan view. We could even, let's say I could export something to GIS. Maybe I'll export this facility and all its details. I could export this all out to GIS. So there's the shape file. Yep, and I want to push that back out. So I've exported all the CAD details, all the pipe network, and all its 3D information. Export out to GIS. Maybe just some basic reports, right? Maybe your drainage report. Now that the civil team, the site team is satisfied, they have all the details to finish that final grading. Let's see, let's go to, we could start looking at maybe inflow summaries, right? So all of this information, perhaps pick the critical storm. This could be a table in our report. Okay, this could be just like I like to use XP tables for this. So perhaps here is some runoff information, and maybe I also want to see max flow and volume. Again, right, this can all be saved out, pushed out to Excel, to PDF, or put right into a Word document, and this is a report. So We're now finishing up our drainage report right from the software. One thing that is, I call it the filing cabinet report, but someone might want to kind of have that master printout of everything in the software. So all the input, well, just file print, we'll see kind of what happens here. I could select all of my properties, and you'll see. So here's all of my runoff information, right, and all of the actual dimensions of the system. Maybe I want to also show some results. Maybe I'll just look at all storms for my inflows. Again, you could turn everything on. I might just turn a few on just for example's sake. Let's do some graphs. Okay, so stormwater control, just turn some graphs on. We'll see what this looks like. All right, we can have all sorts of information shown in this PDF. Okay, and I happen to, all right, so here is all of our information here. We have all the different graph output, all of the, again, filing cabinet report, right? A lot of these are exported and never looked at again because there's so much information. Normally it's the drainage report, but this could absolutely, we save this out. This is that submission folder I was updating, right? We could save this to a PDF, and now this becomes, Appendix A, let's say, in our report, right? So you can see all of the Santa Barbara method and all the input for all these items, so on and so forth. So xpdrainage is, the opposite of a black box. It's any information you have, bring it in, use that, really robustly assess a system, and then kick all this information back out. This submission folder is everything I need to have my site team finish up any grading or any other site items based on the final storm system. This is going to be finishing up any appendix to your drainage report or the drainage report itself. Okay, so that is really the overall workflow of drainage. Okay, that's great. That was what I was hoping to really kind of show and demonstrate in the software. So again, thanks for joining, and I'll have another session. If you'd like to check this out again, I'll be presenting again in just a few hours. Thanks everyone, and have a good day.